Ever wonder why some peer reviews read like glowing endorsements, while others feel like a cold critique? A groundbreaking study has uncovered startling patterns in how scientific feedback is shaped, not just by the research itself, but by the identity, gender, and geography of the author. Let's unpack this critical discovery and explore why it matters for the future of science. Peer review is the backbone of academic publishing, but it's far more than a simple good job or needs major revisions. It's a nuanced dialogue, and this study reveals how that dialogue is quietly influenced by hidden biases. Researchers analyzed thousands of reviews, digging into the language, tone, and context of feedback to uncover systemic patterns. What they found challenges the myth of objectivity in science. Let's start with the big picture. The language used in reviews isn't neutral. Papers from top-tier institutions often receive more measured, balanced feedback. Why? Reviewers may unconsciously give the benefit of the doubt to work from prestigious universities, assuming higher quality. But for authors from less renowned institutions, feedback is inconsistent, sometimes overly generous, other times excessively harsh. It's like a double standard baked into the system. Now let's break it down by identity. Early career researchers face the harshest scrutiny. Female authors, particularly in the early stages of their careers, often receive more positive feedback than their male counterparts. But here's the catch. Male authors, especially those from non-Western countries or underrepresented groups, face more negative critiques. Meanwhile, white Western researchers consistently get the most praise, especially when they're just starting out. These disparities aren't random, they're systemic. How did they uncover these patterns? The team used statistical tools like regression analysis to isolate variables, like gender, race, or institutional prestige, and see how they correlated with review tone. They also applied natural language processing, NLP, to analyze word choice. Phrases like great work versus needs major revisions revealed subtle biases. For example, marginalized authors received more correction-focused feedback, akin to a teacher giving detailed notes to some students but not others. Here's where it gets even more complex: anonymity. When reviewers remained anonymous, biases spiked. Female authors received more praise, but non-Western researchers faced harsher critiques. However, when reviewers signed their names, feedback became more balanced. It's as if anonymity emboldens harshness, while transparency encourages fairness. This suggests that the current system may inadvertently amplify inequities. The study also used AI to classify review tones: appreciative, constructive, questioning, or critical. When reviewers knew the author's identity, they asked more questions and offered nuanced feedback. But certain biases persisted, like critical tones targeting authors from non-top institutions. This highlights a paradox. While transparency can reduce some biases, it doesn't eliminate them entirely. So what does this mean for science? Peer review isn't just about the work, it's about the people behind it. Anonymity can amplify bias, while transparency may encourage fairness, but neither is a perfect solution. The takeaway: our systems need evolution. Journals could experiment with open reviews, bias training, or structured feedback frameworks to ensure science is judged on merit, not background. Next time you read a peer review, ask yourself, what tone is being used here and why? The answers might reveal more than the research itself. They could expose who gets heard and who gets silenced. Thanks for watching. If you want to dive deeper into the data, check the links below. Stay curious, and let's keep pushing for a fairer scientific future.